Hello and welcome to this look at a typical recall-based exam question using amino acids. So here's your typical amino acid structure. You've got an amine group and a carboxylic acid group on either side of a carbon atom attached to a hydrogen atom, and then you've got an R group which can actually be potentially additional functional groups. This actually is called an alpha amino acid template. So when they talk about alpha amino acids, this is the kind of thing they're talking about. So when you're doing amino acid chemistry exam question, the kind of thinking to apply is to remember that amino acids often contain more than just the carboxylic acid and amine functional groups. So looking at some examples, you can see there's a carboxylic acid, and also you've got an amine. And in one of them you've also got an alcohol, an OH group. So let's have a think about the different reactions these could get involved in. So already you can see that there's actually any one of these amino acids could do lots of different things. This one asks, many amino acids have several functional groups, and serine shown below is a naturally occurring alpha amino acid. So what they want you to do is draw the structure of the organic products formed by each reaction. So in reaction 1 you're using a base, and that's obviously going to react with a carboxylic acid functional group. So the alcohol and the amine won't react. You can see there's an alcohol functional group here and an amine functional group here. So they get left alone because a base will only react with a carboxylic acid to make a sodium salt, or carboxylate salt. So the next reaction, you've got a primary alcohol. It's not a phenol, because if you look, there's a CH2 there in between the OH and the benzene ring. So we don't treat this as a phenol, we treat this as a primary alcohol, even though it's got an aromatic ring. So the COOH group will react, but this time it's an esterification. And also you'll get a salt. So you can see there's a second mark available there for putting NH3+, so that's where your 3 marks come from. So let's take our serine molecule, and what I'll do with the next section is just explore the ways in which serine could be made. So it says one possible method of synthesizing serine is shown below, and I'm just going to take you through the changes. So rather than actually do the question and what specifically they're asking for, I'm just going to explore the functional group changes as you go from one thing to another. So in that first reaction, reaction 3, the chlorine is substituted for an NH2 group, and all the other functional groups are unchanged. So what's happening here is nucleophilic substitution, which requires NH3 with an ethanol solvent to avoid the water behaving as a nucleophile. So in reaction 4, you've got a primary alcohol which is being oxidized to a carboxylic acid, requiring reflux with acidified dichromate solution. So that's what you put in there. And finally, you've got an ester functional group that's becoming a primary alcohol. So therefore it must be being hydrolyzed, requiring heat and a concentrated H2SO4. Okay, hopefully this has been a useful quick look at how organic synthesis can be applied to amino acids, and remembering also that amino acids themselves have a number of different reactions they could get involved in. Thanks for listening. Until next time, see you soon.